Okay, hello Math Contest Club. Today we're going to go over question 8 from Euclid 2023. After looking at the problem, we can just grab some key informations. First, we have a right angle triangle ABC, and we have some conditions to this. AB is equals to n times n plus 1, and AC is equals to n plus 1 times n plus 4. We have the condition that n is a positive integer, and we also have the number of, and the question wants to determine the number of positive integer n for n smaller than 100,000, that the silence of BC is also an integer. Now we could express the problem in the terms of math. First, according to the Pythagoras theorem, we have n plus 1 squared times n plus 4 squared minus n squared times n plus 1 squared, and square root of the whole thing is equals to the silence of BC. This thing have to be an integer. After simplifying this, we had n plus 1 times square root 8n plus 16, which could be further simplified to 2n plus 1 times 2n plus 4. This thing have to be integer. This means that we have 2n plus 4 to be a positive squared. Take a moment to think about how could we find all positive squared that have n to be smaller than 100,000, but also have 2n plus 4 to be a squared. Two n plus 4 can be expressed as 2 times n plus 2. And we could know that this thing also have to be a positive square. Now we can define a new variable k to have 2k squared equals to n plus 2 for k is belong to integer. Now we have the conditions that n have to be bigger than 0 and k have to be bigger than 1. Then we can give a chart to express this. K can be 2, 3 to a certain number, while n could be 6, 16, and to the last possible square that is smaller than 100,000, which is 99,456. This means that n is 2023. This gives us that there are 222 possible n that can make BC also to be an integer. Therefore, our final answer is 222. Okay, now we can move on to the second question, which is part B. This question is a typical log question and is pretty classic. First, after looking at the problem, we can just simply find that we're solving for x. And if we set n is equals to log base 2x, we will make our life much easier. Now, the original equation will be square root n times n plus 2 plus 1 plus square root n times n minus 6 plus 9, which is equals to 4. After opening the bracket inside the square root, we can simplify that there's all perfect square notation inside. This means that we can just simplify this as However, this is where the tricky part comes. We can see that we can have casework now. Our casework is simply that 1, n plus 1 is bigger or equal to 0, and n minus 3 is also bigger or equals to 0. The original equation will give us n plus 1 plus n minus 3 equals to 4. This means that n is equals to 3. If we substitute n back in, we'll get log base 2x is equals to 3. X is equals to 8. By the way, this case is only suitable for n bigger or equals to 3. Now we will have the second case. This case is n plus 1 is bigger or equal to 0, and n minus 3 is smaller than 0. This will give us the condition that n is smaller or equal to bigger or equal to negative 1, and smaller than 3. This will give us n plus 1 minus 3, n plus 1 minus n minus 3 is equals to 4. This means that 4 is equals to 4. Then all real number in this range will work. Then if we substitute back, we will have log base 2x belong to negative 1 to 3. Then x have to belong to 1 over 2 and 8. Then we have the third case. The third case is n plus 1 is smaller than 0, and n minus 3 is also smaller than 0. This will give us the condition that n is smaller than negative 1. We will have negative n plus 1 minus n plus 3 is equals to 4. Negative 2n will be equal to 2, n equals to negative 1. However, there is a contradiction. This case have no solution. Moving on to the last case. That's the direct opposite of the case 2, which is n plus 1 is smaller than 0, and n minus 3 is bigger or equal to 0. This gives us that n will have to be greater than negative 1. n will have to be smaller. N will have to be smaller than -1, but also to bigger than 3. This is not possible, so case 4 does not state. Then we can conclude our solution. This means that x will fall in the range of -1/2 to 8, and every single real number of x will work. This concludes our solution.